In this session, I'm going to be creating a normal distribution calculator, the t distribution calculator in Excel. Now, you can, of course, use a t-table to read the t distribution, but I am going to create a calculator in Excel so that we can reuse it multiple times to answer questions, especially questions with single sample test of hypothesis. First thing I do is start with a clean Excel sheet and then decide where I'm going to put the calculator functions. Here, I'm going to create labels. And after I create those labels in the column C that you're looking at right now, next to it, I'm going to create input cells. The idea is for someone who wants to use the calculator to put an input value in those input cells and then have those values feed into all of the calculations required to build a hypothesis testing calculator. So this is not a tutorial on how to do hypothesis testing. This is how to create a calculator in order to have something on tap that can do hypothesis testing. Oh, and by the way, if you want to speed this up, you can play the video uh, at double time and mute the volume, and then you don't have to listen to me narrate what I'm doing. It's a pretty self-explanatory. I've typed in all the labels for the input, and part of what I like to do when I create any calculator or model in Excel is make sure everything is properly labeled and understandable. So I'm using symbols here to indicate that I'm going to be putting the hypothesized mean value into the cell. I'm going to put in a symbol for X bar. That's the representation of sample mean. It just makes things clearer and prettier when you're setting up your model. For standard deviation, I'm going to go back into the Insert tab and select Symbol and pick out the symbol for mu. So that's it. I've put in brackets and I've typed put the X bar equation in the bracket so that it looks just like the mu above. I'm going to do the same thing for standard deviation. It keeps things a little bit consistent, not a little bit, actually, a lot consistent. That's what I'm looking for, consistency in the design. And it would be obvious when I get to the end. I should say that this is the first of 4 parts. I started with a basic calculator, and then gradually can I say tush? I tushed it up a little bit. I added bells and whistles just to make it look nice and look better. So that's where I'm going to put my input cell. When I build calculators like this, I like to mark the inputs and make it very, very obvious that these cells are separate and different from all the other cells and values in my worksheet. So I selected everything, went to the borders drop-down menu and selected all borders. Now I'm typing values in it. When I build calculators, I keep saying that, but when I build calculators again in Excel, I like to begin with values so that I know when my formulas are referencing the input cells correctly. So I'm moving it down to make space for labels and the rest at the top. I have something in mind for a calculator. I'm building a T distribution calculator right now for mean, and by the time I'm done, I'm going to have one calculator that can be flipped so that it will work on the t-table, and you can also do a z distribution calculator as well, and you can use it for proportions of mean, and you would also be able to do a one tailed test or an upper tail or lower tail test if that's what you prefer. So the type of test button here or cell here, I'm going to use it in my formulas when I'm programming it at the bottom. I'm basically going to allow my formulas to change depending on the type of test I'm running. Since I plan to use it for multiple tests, it just makes sense that I create an input cell for me to check what type of test I'm doing so that I can decide which formula will go up. You're going to see me do a lot of trial and error in here. Everything I'm doing is not because I have a rough design in my head, but I've done so many of these that I don't sit down and plot it out 100%. So some of the things I'm doing might not work, and I might have to go back. For the T table, you need degree of freedom, right? So that's where it is. The formula for degree of freedom is just count. I select sample size -1. Standard error is the standard deviation, and you're going to see me type equal to, and then I'm going to select the standard deviation because that's the numerator, and I'm going to divide it by the square root of sample size. Now, as I'm typing, notice there are no numbers in any of the formulas I'm creating. That's the essence of creating a calculator. I want to be able to have input values put in at the bottom, and then I want to use Excel's formulas and functions to work on those input values, calculate with those input values and generate output. So that's what I've done with the standard error, and all the formulas I have below here uh, won't contain any numbers. Now, at the moment, I'm trying to figure out how many decimal places I should have. I like having 2 decimal places, but when I'm done with this calculator, I'm going to be giving it to my students in my business statistics class to work with. And not everyone is an Excel expert. Not everyone has seen Excel before. So they don't know that they can change the number of decimal places. So I kind of try and preempt what they're doing and jump in and think about how they're going to do this wrong and try and accommodate that in the design. So I need alpha for my calculator. I need alpha divided by 2. This is me trying to figure out what to call that cell. I'm not quite sure what I want to label it. So figuring it out as I go. I'm going to decide what I want to call it eventually. This is just me. I like my work to be very well labeled when I'm building it. And I like to build things once and not have to go back and fix it. So taking me a minute to get through this. My alpha is 1 minus the confidence level, or 100% minus 95%. Excel's not very fussy, 95%, the confidence level is in decimals. It's being formatted as a percentage number, but it actually is just decimal. So you can do 1 minus confidence level to find alpha, or 100% minus confidence level, and you'll get the same thing. That's the formula for my T statistic. My test statistic is what it's called. My T test statistic. Notice that I need the answer for standard error. Oh, 1 minute. This is me. I'm formatting that. I'm using Format Painter. I already have a format that I like. So I select the cell that has the formatting that I like. And then I use the paintbrush to paint it onto other cells. And I'm going to do that multiple times. Anyway, the point is, when I'm calculating the test statistic, I'm taking a numerator and dividing it by the standard error. And when I get to standard error, I just select the standard error I've calculated before. It's good practice to only input a value once. Have one input cell for each value you're going to use in your calculator. You don't do multiple calculations because why? You just select the calculations that you have from before. Now, I could have just taken standard error and rolled all of the formulas into the t statistic instead of breaking it up into chunks, right? I just decided that it's better to break it up into chunks because each unit of information is meaningful. It's useful for me to know what the degree of freedom is. It's useful for me to know what the alpha is and standard error and so on and so forth. Here, I'm trying to figure out what formula I need for the critical t value. I probably would have benefited from writing all this down before I got to this point. But in order to calculate the critical t value, I need alpha over 2 for a two-tailed test. And I also need the degree of freedom. And I'm going to use an inverse t table. So for those of you who use tables for statistic, you would use a Z table, a paper version, and look in the body of the table to find your alpha over 2, and then go to the edge of the table to find out what t value it relates to. Don't have to do that because Excel has a great function. It's called t inverse. It's the inverse to the t table. So now I'm going to calculate the p-value. The p-value is the probability that I get a more extreme value, right? That's TMI, I suppose, too much information because I'm not teaching you stats. I'm teaching you how to do a calculator. So I'm going to put the formula for the t-value in here, p-value. And that formula uses it would use the t statistic, and it would calculate the probability of getting that t statistic, a probability of getting a more extreme value than that t statistic that I have. Okay, I didn't have to, I basically answered most of the questions I want to answer with the normal distribution calculator. I'm not going to lie, right? If the t statistic is between the positive and negative value of negative forms of the critical value, then I can reject the null hypothesis. Otherwise, I don't. So I have the t value and the critical t value, and both of those things can give me enough information as to whether I should reject the null hypothesis at this point. But I'm doing all of the forms that you can use to figure out whether you should reject the null hypothesis or not. The p-value, if p is less than the alpha, then you reject the null hypothesis. So that's a second method that will help you. Now I just need to decide how to tell people whether to reject or fail to reject the null hypothesis. So I'm going to use an if statement, and I'm going to use the p-value method. If p value is less than alpha, reject the null hypothesis. Otherwise, don't reject the null hypothesis. And if you do reject the null hypothesis, then I want you to do it with a statement. It would be reject or fail to reject, or something like that. Do not reject, maybe. So do not reject and reject. So if I tested if statement, if the first part of the if statement gets done, if it evaluates to true, do not reject is printed. If it's false, then reject is printed. In this case, you can't reject. So yeah. Now I'm going to do a third method for hypothesis testing. I'm going to create a confidence interval around the hypothesized mean. That's just the third method, right? I can then look at the sample mean that I have and compare it to the hypothesized mean confidence interval. And if it falls between the two, you don't reject the null hypothesis. Otherwise, you do. Again, overkill, overkill. But I'm creating this calculator to teach a concept and to teach a class. So I want it to contain everything you could possibly use. Now, if you're just wanting to learn how to create a calculator, I suppose you could um, get some ideas from me on good modeling practices, good modeling behavior. That's it. So in this cell now, because I'm going to use this calculator for multiple things. If you want to see how I modify it in the future, then please go and have a look at the other parts of this exercise. I used the AND formula to concatenate the text confidence interval around with hypothesized mean value, because I might change that label if I'm doing test of proportion. So I might put in there an if statement to change cell B5 if I was doing a test of proportion. So and I also want my calculator to change depending on what test I'm doing. This is the formula for the lower bounds, and I'm then going to put in the formula for the upper bounds, and then that seals this formula. So what are the key takeaways from this model that I'm doing for you right here? One, when you're creating a calculator, you need to create your input sheet, use your input cells usually at the top of the page and away from all of your calculations. You need to make sure that all of your inputs are labeled so that anyone using your calculator knows what should be going into each of the cells. And you need to make sure that your input cells are properly consistently formatted so anyone looking at it can identify. Once they know that this is an input cell, they'll be able to identify it all over your model, anywhere in the model. So now I'm just going to do some formatting, I think. Format things, make them look better. I've centralized that. I'm going to put this in the center. After I test the calculator, I'm going to make additional changes. But for now, right now, I like things to be in the center. It has a certain poetry to the way it moves. So that's what I'm doing. I'm just putting all of my data in the center, making sure everything's consistent. I've covered as much of the bases as I can. I'm trying to make the labels bold. Then I remembered that I've got merged data. And if my data is merged and I'm selecting it, it's going to select all of the cells across the merged data. I'm putting thick borders around my headings. I'm labeling everything. As you can see, I've got my type of test, the input cells at the top. I've got my intermediate calculations labeled as such. And then below that, I have confidence interval around hypothesized mean. That is also labeled as such. I've put some background colors in it. I'm a color fiend. I love, 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 love colors. And I suppose this is a place where I should say, before I became a professor of finance, I used to build applications in Excel. So I worked for a company and they did accounting and reconciliation. And I used to build a lot of applications in Excel. So I'm not a novice, right? I do this a lot. And I enjoy making my models efficient and clean and making sure I don't do it more than once. What I'm doing right now is putting in conditional formatting. I went to the Home tab, clicked on Conditional Formatting, the Do Not Reject tab. I want the color to change based on the tab that I put in. So this is me trying the first thing. I used if text contains Do Not Reject, make it green, make it red. And then I tried doing if it contains reject, make it green. The problem is Do Not Reject contains reject. So when I change that field to green, see what happens? So If I was doing this in a programming language, I would have used regular expressions to make sure that I exactly match reject. But Excel doesn't really have native support for regular expressions. So what I'm going to do is use another conditional formatting form, the equal to. Now I need to match the text exactly. So if the text in the cell matches reject, then you reject. If it doesn't, then you don't. So I'm going to go back and take another stab at this conditional formatting thing. I'm in thinking mode. I use Excel a lot, but I can't remember all of the functionalities off the top of my head just like that. So, ha, I got it. Now I'm going to go back, look at the, instead of doing text contains, how about we go back and manage the rules? I think I'm going to delete this or edit it. I'm not sure what I did to this. Let's see. Oh, I'm still in figuring out mode. Figure, think. I've done this multiple times. I have other calculators that I've created. I have other functions that I created. Tend to write Visual Basic Code, simple Visual Basic Code in Excel if I want to automate stuff. So, but sitting there right now, I'm trying to figure out what to do, and I'm a little bit lost. Not lost. It's just taking a minute. I don't want to fast forward it and then have to go back. So what else should I be telling you? You know what? If there's no data in this section, I'm going to wipe it out. But what did I say takeaway was? Oh, here is the takeaway. Inputs separate, calculations separate, uh, answers that matter, you should format it so that it jumps out. That's why I'm trying to format where it says reject, do not reject. I want it to jump out once you put all the values in because that's the most important piece of information here. So, okay, so that's what I've decided to do. I'm going to clear all the conditional formatting rules and then go back and use the equal to. If you look at the top, I've said equal to format cells that are equal to. So that's what I'm doing. Yeah, we'll wait. Do not reject. So it exactly has to match do not reject. I like the light red. If I didn't like it, I'll use the drop down to select some other conditional formatting values. Okay, I'm going for green for reject. And then we'll put another one in for do not reject, and I'm going to go for red. So do not reject the null hypothesis versus reject the null hypothesis. Awesome. So that's me. Now I'm just going to clean this up and make it ready to go. I could give this to my students now, but I've still got some additions to put to it. I've got to get the calculator to work for different kinds of tests and different kinds of tables. I think I have about 9 tests in mind. And instead of giving my students 9 calculators, I'm just going to use the one calculator and have the calculations change depending on choice. So yeah, here I am uh, checking. I'm going through, making sure that the calculator works. I'm testing it, changing the hypothesized value. What you can't see, what I've got off screen is a piece of paper in which I've done some of these calculations that you're looking at. So I'm testing it. I'm making sure that I get what I expect to get. I hope that makes sense to you. If you build a calculator in Excel, you want to do some extensive tests on the calculator. And as much as possible, that's what I'm doing. I don't like that the reject value is green, so I'm going to change the text to black so that it's more, it's more solid. But that's just me. That's choice. I like things clean and colorful and neat. So that's just choice. Oh, like I was saying, I've got all the data set up. I've got test values set up, and I'm just going to run those values through the calculator, make sure I get what I expect. That's proof that the calculator on the surface seems to be working. And then that's it. So thank you for hanging in there. I'm going to complete the work, next of the work in part 2 of the tutorial.